Too many alerts and not enough action? It's time to get Saltstack. Saltstack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With Saltstack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/Saltstack to learn more. SysDig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using SysDig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. SysDig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using SysDig. To learn more, visit securityweekly.com/SysDig.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. We're currently running two surveys, the 5 stages of automation maturity and our annual listener feedback survey. Please visit securityweekly.com, click the survey tab, and select 5 stages of automation maturity or 2019 listener survey to submit your response. The new Security Weekly website is officially live. Visit securityweekly.com to check out all of our new sorting and filtering functionality. Please let us know if you find any issues or have any feedback by sending an email to website@securityweekly.net. Well, this week, guys, I have a small article about a breach, but I thought what was more interesting about this was the long-term threat of MageCard. So here is a P&G online beauty store hacked to steal payment info. But the way this was hacked and the way that literally over the last 10 years, effectively, many websites have been hacked is essentially an e-skimmer. Which is the fancy way of saying some JavaScript blobs being inserted into the web page to sniff and siphon off the payment information from an e-commerce site. So this is the virtual or the cyber version of a skimmer that we've read about being put on like gasoline pumps, stealing physical card track data. And the couple things about this were, one, the Magento e-commerce platform is a bit rusty and a bit has quite a few holes in it. So it's one of those applications. Exactly. It's that category of when did it ever have a non-critical update for it. So unfortunately, always getting that, which is unfortunate because it's a lot of the small and medium businesses that rely on this type of software are the ones that are also now being targeted by MageCard.
Yeah, there are only 56 vulnerabilities, 10 and 11 at a 9.1. So yeah, a little vulnerable.
Yeah, a little vulnerable. Yeah, it's the Adobe Flash of e-commerce, unfortunately. Sorry, Adobe.
What I thought was actually interesting is this was targeting, was it non-US? It was a very targeted attack. It was looking for specific people to attack, not everybody. It had some sophistication in this.
Yeah, so it's definitely the group or groups behind this, they have gotten to the point where they have their own Jira ticketing systems. They have their own DevOps and infrastructure to manage all of these compromised systems and all the data they're collecting. And Matt, what you were referring to is that in this case, the e-skimmer, the JavaScript, would not trigger for people coming from US or if they were running Linux systems. Browsers from Linux systems. And ostensibly that was to avoid detection by security researchers. If, thinking that most security researchers are probably not running a Windows system with Internet Explorer or Edge or Chrome for that matter, because it doesn't really matter how secure your browser is. But it was just one of those ways of that cat and mouse avoiding detection so that it can sit here and not just be compromised with a particular website for a few days. I think 22 days was one number, but for several years, if not indefinitely. There's a lot of instances where these haven't even been cleaned up from an e-commerce site.
Yep. Yeah, I just thought the sophistication was interesting because there were certain scenarios that this thing would not trigger. So it was somewhat advanced in the way that it worked and very selective on who it was targeting.
No, absolutely.
It really puts a smile on my face when I hear the bad guys having actual mature processes like a CI/CD and like a ticketing system or something like that. That really just, I don't know, that warms my heart somehow for all the wrong reasons.
So to be even scarier, John, if you think about some of these dark web kind of bulletproof data centers, their processes are more sophisticated than almost any organization on the planet. We actually did an interview on PSW a few weeks back. I mean, these guys are highly sophisticated when it comes to their processes, their automation, the way they code and develop. I mean, highly, highly advanced underground entities out there.
Yeah, that's awesome. So quick question, is Magento, I've been lucky that I haven't had to look at Magento for about 5 years. Is that still install based, right? It's not a service yet?
Yeah. Yes.
Okay. So the reason I say that, this is, especially in this year, this is a great reason to be using a SaaS instead of using install it yourself. Not Spotify, Shopify is like, let those guys go and do this stuff for you. You think it might be, well, Magento's not free, so you can't even use that as an excuse. Just go and do a SaaS. Don't be running this stuff yourself.
There is an open source version, though. There is an open source version. I don't know how much functionality it has, but it does have an open source component.
Oh, okay.
Yeah, it's sort of like, and it's sort of like you could either download and run your own WordPress, or you could run it through, for example, WordPress.com, and you're essentially shifting the burden of all the security updates, security management, and what have you onto someone who should be more the expert and who is actually, you're paying to do that on a daily basis, rather than trying to figure out your own and say, oh, yet another update, now I have to figure out how to do that.
It's how we run our website. We use WP Engine to maintain all the core stuff, and then we're responsible to keep the rest up to date. Yeah. Makes life easier, but it's a little bit of a pain in the butt every once in a while when we have to move stuff around. It's a little slow, but.
Well, when we start selling application security weekly T-shirts off the site, we know we can just have to update our Magento.
Right.
Get Paul working on that.
Get Paul, yeah. Another thing we could get Paul working on, we could go, full out super Kubernetes deployment to run the website, and we could use K-Rail from Cruise to manage the policy enforcement tool for Kubernetes. So I highlighted this is essentially because it has the buzzword Kubernetes. It's also coming from another I was going to say startup, but another tech company that's a little bit more mature, that's essentially running into probably a very common problem of managing Kubernetes workloads, and just saying, here is now a contribution to open source for this. And I haven't really dived too deeply into it. It was more of a area of interest and something to highlight, just because it's showing that there is the community discovering security problems within especially multi-tenancy clusters. How do we make sure we're setting up good, strict boundaries of isolation that can't be crossed by peers within this cluster, and enforce some of the security expectations we have around all of these containers?
So we wouldn't actually run WordPress in Kubernetes, but we are working to get our post-production software running in Kubernetes at some point, right? And so, we are containerized ourselves for our post-production app. And one of the things we've been talking about is, eventually being able to move this into something like an EKS or a Fargate to run for us, so that we don't have to manage the underlying infrastructure. Because, look, a lot of people like building their own clusters, but managing clusters and growing them, expanding them can be a lot of work, right? But tools like this are going to be important for those organizations that decide to roll their own Kubernetes and need some protections. And again, a variety of easy privilege escalation routes. Yeah, like giving somebody a privileged container on a Kubernetes cluster and giving up root. This is why we talk about this stuff, right? Because there are lots of ways to bypass and create privilege escalation issues that then create issues when you have a multi-tenant environment. And I think where we'll see usage of some of this is actually the cloud providers, as you think about how to do some isolation across multi-tenant environments in something like an EKS or a GKE or an AKS at some point, right? Because you're not going to want customers to be able to cross boundaries on the same Kubernetes cluster so their apps can't cross-contaminate each other. Great tools. My guess is they do some really good policy validation stuff in here. We're also going to see a ton of commercial products coming out to also that are already trying to address this space as well.
Yep. So I'm just taking a glance at this. I hadn't heard of this one yet before this morning. So my first thought was I thought it was implementing an admission controller, which is a Kubernetes concept, and I was going to make some comments about that because what we're seeing. So we're looking at admission controllers quite actively right now, and one of the problems with admission controllers, because that one actually allows you to say before, it's why I call a pre-execution check, right? So it's not a scan and it's not a running container. It's right when you say, hey, I want to run 10 of these. If you have an admission controller Kubernetes, you can say, check to see if I've scanned it before or if it, passes whatever my policy is. The problem with that is you have to have a security API. And some of the hosted Kubernetes offerings out there won't let you do that. Some will. So that's just something to think about. But this looks like it's more sort of probably closer to KubeBench or KubeScan. That's another running process, which is checking what's going on around it. Still a good thing to have. I'm not trying to belittle, just trying to sort of figure out which pigeonhole it goes into.
But I am assuming this has to run in your Kubernetes environment and not. Yeah. This isn't going to be something that runs in an EKS or something like that, right? You're not going to be allowed to run at that level in a shared environment like that, right?
I think it would, looking at it. I haven't tried it yet, but my sense is it runs through a Helm deployment. So that's going to run in the cluster.
Interesting. Yeah, I'll have to check it out.
Yeah.
There were two other articles that sort of kind of lumped together as a lead in to, I'm going to foreshadow, talk about the state of software security. But the lead into that was an article a little bit earlier this month, just talking about DevOps and the proliferation of secrets, that I thought was a pretty good, just a nice overview of all the different types of secrets that applications need and where they go and where especially all the components that are building applications also need secrets. So pretty much everything that isn't a human has a secret or credentials that are necessary to manage. And it goes through a couple questions, leading questions about that would be great departures to threat model, how you're handling the secrets, what you should be doing to manage them. And so, there was that article that also ties into this other one about the top cloud security controls you should be using. And one of those controls, of course, is how you are managing credentials, both for humans having multi-factor as well as services being able to rotate and using vaults or using like KMS within any of the cloud providers. And I think, let's see, there was another one that was also these security controls. The other thing, too, it also talked about protect the data. And that was the other one that I wanted to kind of highlight and just reiterate, too, is that we've often talked about protecting the app in terms of defending it against a injection-style attack or preventing a misconfiguration. And yes, those do lead to data exposures, data leaks, data compromises, but there's also ways that if you just start off by encrypting data or hashing data, or for that matter, designing your app so it doesn't need to even collect data or it just holds it for a very short period of time, is very ephemeral, those are also a very effective ways of protecting data on top of doing the right things in terms of preventing injection, checking for misconfigurations, and so on.
So the second article is in line with a session Paul and I did about a month ago on Enterprise Security Weekly, which is talking about the shared responsibility model in the cloud. And therefore, what am I responsible for versus what is the cloud provider? And it varies, right? I think the one thing that you can't, there is no simple answer to this because it depends on the type of cloud service you're using. But there are some things that are common across the board. Identity and data are your responsibility no matter what. It doesn't matter whether it's running IaaS, PaaS, SaaS, doesn't matter. You have to manage identity credentials and you have to protect your own data. It doesn't matter where it's running. App is the other one that comes in there at various layers depending on how the application is being run or architected, right? Because there's going to be varying levels of degrees of what you own in the stack. And then other things like network and endpoint really apply into infrastructure as a service, not necessarily in platform as a service and layers up. So if for anybody who wants a really good breakdown, we kind of broke down the different shared responsibility models and some of those high-level controls that you would be responsible for in a cloud environment. It's a good place to start. And this article is pretty much online with what they kind of mention. But like I said, identity and data are always those two you're going to own no matter where these environments are. You have to be able to manage those and protect those, because if you don't, you're really going to be hosed.
Yeah, these are both these articles. They're not rocket science, but I think they're good for folks to review. On the second one, the controls one, the first bullet hits home so hard. And like, Matt, you were just talking about the responsibility, the balance of responsibility. I think folks are becoming a little more understanding of that than where they were. But like, when I was doing a previous startup, I'd walk into an executive or a VC room, and I think we've talked about this before, and they'd be like, wait, you're telling me that like Amazon's not securing things? And I can tell you right now that all the large providers they're doing a lot of stuff preactively this year, but they're still, it's still on the end user to make sure that whole stack is controlled, or secured.
Yeah, I mean, there were articles. I didn't want to get into the political aspects of this, but they were reviewing the Capital One data breach in Congress last week, and they want to open investigations on the cloud providers. I'm like, why? The cloud it was a misconfiguration in a service that was owned by Capital One. Unfortunately, it wasn't an issue necessarily with cloud security, and so you're seeing people take some very interesting leaps of what the cloud is responsible for and not responsible for, which is why we built that matrix, is because a lot of people were confused. And I think it's good to clarify, if you're running this type of cloud, this is what you're responsible for. If you're running this type of cloud, that's what you're responsible for. Because they do vary. There is no simple answer here. And to have Congress step in and say, now we're going to start to review the cloud security vendors, that doesn't make a lot of sense to me when the shared responsibility model should be pretty well known at this point, but sounds like it's not.
Yeah, I understand why your initial comment on that, and I'll say it's probably related to that announcement last week with Microsoft winning the government contract.
I don't care who wins what contract. I think Congress just needs to understand where are its boundaries and where aren't its boundaries when a breach happens. And the responsibility sits on the company in most cases, not necessarily the cloud provider.
Yeah, but I completely agree with you. I'm just hinting at the politics behind it.
Oh, okay. Maybe.
Yeah. And I think, and there are some interesting, and while I don't think there's a political or legislative solution to dive into a lot of the technical issues, especially around Capital One, there are some interesting technical aspects around it, because if you go back and look at what seems to be the fact pattern of the compromise, is that a SSRF basically exposed the local metadata service on a EC2 instance. And that was really trivial to exploit, because with an SSRF, if you can just hit that with a naked URL, it's exploitable. If, however, you had to provide a specific user agent, or you had to provide an additional header, whether it's an identity header or even an authentication header, even better, that suddenly becomes extremely difficult to exploit. And so when you start to compare, access to the metadata services and how that's modeled between like GCP, AWS, or Azure, you do start to see some technical decisions that the different cloud services providers have made that are essentially making, hardening them against various attacks. And so I think there is a very good and interesting technical discussion to be had, not so much on perhaps where the responsibility lies within a breach, but how cloud providers can do things perhaps a bit more proactively. For example, Amazon finally coming around with better ways to highlight when a S3 bucket is open to the public and not making it so easy for administrators to make that mistake from the beginning.
No, I agree. They need to make it easier to find, but at the end of the day, the customer has to configure these environments correctly, and nobody thinks misconfiguration sexy, but what's leading to all these breaches in the cloud? It's misconfiguration.
That's right. We're bringing sexy back, Matt. I think that's what you're saying. And that's what Veracode has been doing for the last 10 years with their state of software security. So this is the first year they did this. They had a population of about 1,500 applications that they drew their analysis from. This time around, they have roughly 85,000 applications that they've scanned. So this is a good tie-in to our previous segment that was talking about dynamic application testing. They're coming from the perspective of source analysis. So looking at that source analysis, they went through these 85,000 different applications, and we're just looking at how often, what was the frequency of scanning? Were they bursty? Were they continuous? How long did it take to fix vulnerabilities? Was there a correlation between DevOps practices or the amount of scanning and vulnerabilities being fixed? And a couple other metrics I thought were kind of interesting is that the average number of days to fix a flaw in Volume 1, so their first time around, was 59 days. Now the average day is 171 days. So there's a couple ways you can interpret this. One is that scanners are just getting better. They're finding more vulns. Another part, and this is a little bit more of the theme they were teasing out, is that they're finding more vulns, and they're not necessarily all P0 that have to be fixed today. They're immediately high risk, but there's this security debt that keeps accruing because developers are doing a pretty good job of jumping on the high risk vulnerabilities when they come up in a scan, but these medium and definitely these lower risk vulnerabilities are just accruing and accruing and accruing, and just taking a long time to fix. So I thought that was pretty interesting and speaks to that idea of even when you have DevOps teams that are modeling good security behaviors, you still have engineering decisions to make, in the sense of there's only so much time of the day. Do we build a new feature or fix old code?
Yeah, but when you look at the DevSecOps effect stats in here, right, it says more than a 3x reduction in median time to remediation if you're in that model, right? 5x less security debt, and more than a 3x boost to a fix rate. So we know that DevOps and the integration of security into that pipeline, at least in certain areas, can have a benefit. So I'm a little surprised that we see security debt continuing to increase if DevOps is really the mainstream. That tells me DevOps is not really the mainstream yet, and that we still have a lot of older processes that haven't dealt with this technical debt in a way that is efficient, like the DevOps process. Because if you look at their numbers, the DevOps numbers look really, really good compared to the rest of their data. So I thought that was a little odd.
Yeah, I think one of the things that's interesting about that too is that DevOps, to a point in favor of DevOps, you have better testing. That idea of like a CI/CD means you should have better confidence in releasing fixes. So it's not so much that here is a security fix. This is yet another fix. Let's push out, let's patch it. Here's another bug. Let's patch it, push it out, and we have enough testing to give coverage that we can rely on that to move things forward quickly. I think one of the interesting things that we also isn't as well discussed in here, perhaps they do mention it, but that idea that not all security bugs are created equal. And even in the work I've done, I've seen a potential, in effect, there is a SQL injection vulnerability, but there's no really way, there's no good path to exploitation. And so I think what could also be here too, could speak to the idea of DevOps or DevSecOps, appreciating the fact that not all vulns are created equal, And let's deal with the ones that are most consequential, that have a demonstrable path to exploitation. And maybe the others we don't have to spend time on. Or maybe we're going to spend time on architecture changes that just make the impact of someone either exploiting those vulnerabilities just minimal. So we actually can legitimately ignore them.
Yeah, I mean, and again, that comes down to good policy management as part of your overall process, right? If you
Yeah.
know what vulnerabilities are important as part of your static analysis, your software composition analysis, your DAS scanning, et cetera, then you can write policies that say, look, these have to be stopped, these are allowed to go through, and you can have a much more efficient process. And yeah, so maybe some security debt does pick up over time, but we also know that it's negligible or lower on the priority list. That's okay too. I just don't like reports that say, look, we're increasing security debt, but if you're DevOps, you're driving it down. And so what is it, right? Are we driving it down or aren't we driving it down? And a lot of it, I think, depends on how development's actually happening in organizations. And I think a lot of it is still probably a little waterfallish, even though everybody wants to be DevOps-ish. But that's okay. I think these are where you highlight the advantages of being more agile, and the ability to integrate security in allows you to now prioritize vulnerabilities and fix those critical vulnerabilities faster. And it's not about security debt maybe at that point. It's really about optimizing what security issues you really care about to protect your application as it goes through the pipeline.
And I think one of the things that builds that is that DevOps, I think, or that DevOps practices are definitely the way to go, because they do have a line in here about that essentially boils down to the more you scan, the more often you scan, the fewer vulnerabilities you have. So they were saying, like, if you're scanning 300 plus times a year, that has far fewer vulnerabilities than if you're only scanning 1 to 2 times a year. Now, obviously, just scanning doesn't mean that means you're finding the vulnerabilities. It doesn't mean you're actually fixing them. But I think the subtext is that a DevOps team that has this built in as part of their policy and as part of their process, where they're running a scan on every single commit or every single deploy, that means they also have made a security as a first party to their decision-making process. That is a beginning principle of what they are going to pay attention to, so that they are actually going to run a scan and, more importantly, pay attention to the results and fix it. And so I think that part of it starts to build into what you're trying to pull out of here, Matt, in the sense of, if you can run all those scans, that probably means you're not running a waterfall, and you actually have a practice process for doing this that's built into your pipeline, that's actually using APIs to trigger all of these scans and pull back the results. And then someone actually pays attention and responds to it. So vulnerabilities actually do get fixed. And that's why the more you're scanning, the fewer bugs you have over time.
Right, which leads into your last article on the developers, the cause of and solution to security's biggest problems. Because you're right, if you do it that way, they are going to be able to resolve these issues a lot faster, because it's so integrated into the process, and we made security a first-class citizen.
Yeah, and I think I dislike the framing of the title of this, saying that developers are the problem, because that's sort of like saying somehow magically software just emerged and developers weren't involved. But setting that complaint aside, yes, I do like this article quite a bit. Especially too, there's one part of it's just saying, if you're not, you can't tell developers how to do their job and how to write secure code if you haven't written code yourself. That doesn't mean every security person needs to be writing code on a daily basis. Then they're just a developer, which is great. They're a developer with security mindset. But if you don't have that idea of that empathy, is what we're getting to, or understanding what the process is to architect and build and implement applications, then maybe step away for a second and figure out, are you making recommendations, security recommendations, that are actually actionable, or actually take into account context and are risk-based? Or are you just doing this because you're saying, well, this is CVE 9.1, this is CVE 8.6, oh, this is CVE 4.2, so that's okay. And if that's all your decision making, you're not doing any justice to the developer's time, or even a good risk calculation of that application in general.
Yeah, it just starts hitting good points about halfway down through. It's a great quote from John Milton over at Oracle. I only hire developers. I don't hire security people anymore. If you're a security person and you can't code, you should learn now. And I think that really, it drives, that sort of really, we're talking about application security, so that should be a no-brainer to anybody on listening to this podcast. But that could be a little shocking for some folks over on the GRC or the some of the other sides of us, the security world.
Yeah, I mean, Zane Lackey's quoted in here too. Hiring developers on your team allows you to better speak the language of developers and better influence software development to positively impact security. Look, as we continue to see this momentum in the way code is being developed and code is driving the world. I mean, it really is. I mean, if we think about everything we interface with, it's an application at some level. It's a mobile application, it's a web application, it's an API communication between multiples of these. This is how the economy is moving. And to both of those quotes points is, if you were going to be effective in security folks need to understand development, because this is where it's going to happen. It's going to happen way more at this layer than it is at the endpoint or network layer, which is what we've traditionally focused on in the security space. So I think both of these quotes are right on. We talk to our intern all the time. I'm like, dude, you're going to be successful no matter where you go because you understand the code. He has a little bit of security background. I mean, think about the position young people who have great coding skills moving into IT or security will have in the future. This is how everything's going to get done.
First, you're talking about pound sign. Now you're talking about young people these days. Matt, what's happening with you?
I'm just old. I'm an old curmudgeon. I can't change aspects of what I do, but.
So a little bit of Christopher Nolan recursion going on here. If the developers are the cause of security problem, we're saying that security people are hiring developers. That's a little worrying. Maybe we should just turn all this stuff off.
Yeah, like that's going to happen.
Well, I think, I think it's more, vacation. I think a better premise may be that developers are as much a cause of the problem as much as software just has bugs. As if we want to go and have, talk about the old guys not doing smart decisions, I mean, we're still writing front-end applications in JavaScript, which, sorry, going to go there, but it's a little bit of an abomination of language. Cleaned up perhaps for those of you who want to be pedantic and get into ECMAScript. But there are definitely sins of the past that the web applications are still paying the price for, and that's why we still have cross-site scripting to this day. So developers have always been the problem, I think it seems.
We all need to take a step back and remember when Developer Day is and say thank you to all those people who keep us employed.
We should. Yes, we should say thank you to developers as much as I want to say thank you to everyone else who is joining us this week to listen, as well as thank you, Matt. Thank you, John. We're going to see you next week on Application Security Weekly.